So let me ask you this. For this section, this is pretty simple in terms of idea. When you are traveling on an airplane, and let's say you're going 500 miles an hour, okay? And let's say the wind is blowing with you, 100 miles an hour. What is your total speed? 600, right? But what if you're going to the other way? If you're going 500 miles an hour, but the wind is blowing against you, how fast are you going? 400. That's the idea. Okay, does that make sense? So that's the kind of questions that you would have. With water current, guess what? Instead of airplane, you're going to be on a boat. If you're on a boat, maybe you're going, I don't know, 50 miles an hour, and the current is going 10 miles an hour. How fast are you going? 60. If you're going with it, you'll be going 60. What if you're going against the current? 40. That's the idea. Does that make sense? So on your worksheet, it's got what R equals to. What R is going to equal to the rate of the plane or the boat. Depends on what kind of problems you have. So write that down. And guess what the W would stand for? Yeah, the rate of the wind or the water. Right? Or I said current. Okay. And what would R plus W represent? Yeah. Yeah, if you're going with the wind, right? Either on an airplane or a boat. Okay. So the rate of the plane flying with the wind, or rate of the boat with the current. Okay. I could use W for both because wind and current, water, same way. What about then R minus W? What would that represent? Against, exactly. So go ahead and write them down. It's exactly what you expect it to be. It's the rate of the plane flying against the wind, or the rate of the boat against the current. Okay. So I'll give you time for you to write it down. Go ahead. So let's look at our first problem, knowing this is what we need to solve these sort of problems. So here is our first one. Jet can travel, this is on your paper. A jet can travel 6,800 kilometers distance between New York and Paris in 6 hours and 48 minutes with the wind. The return trip against the same wind takes 8 hours. Find the rate of the jet in still air and the rate of the wind. Does it make sense that it takes 8 hours going against the wind? Whereas if you're going with it, it takes less time. Yeah, of course, you're going the same distance. If the wind is helping you to get there, it's going to take less time if you're going, whereas if you're going against it. So what sort of formula do you think it will be helpful for us to use? They're talking about distance, they're talking about rate, time. What kind of formula do you think would be useful? Do you guys know any kind of formula that involves rate, time, and distance? Is this too obvious? Is that why you're not? Yeah, what is it? Thank you. Rate times time equals distance. Okay, so what are our unknowns? There are two unknowns in this problem. Can somebody tell me the two unknowns for this problem? Yeah.
The rate of the jet and the rate of the wind.
Exactly, the rate of the jet. Now the jet is in still air. I wrote this down and I even highlighted, because you could talk about the rate of the jet with the wind, against the wind and so forth. But we're talking about how fast this jet will go if there was no wind at all, right? And so, of course, depends on whether you're going with the wind or against the wind, it'll change. So knowing this then, we're going to do a little chart, because whenever we have rate, time, and distance, it's kind of nice to be able to organize our data that way. Okay, so let me show you the chart. So there's my chart, rate times time equals distance. Now, we're going to have two columns for these, right? What are the two things we're going to have underneath, you think? There are two cases. We're going with the wind, or we're going against. So it's going to be different, right? See, we have two columns down here. Okay. So if that's true, what do you guys think about going with the wind? What would the rate of this plane going with the wind? R Plus W, exactly. What about against the wind, class? R minus W. Is this clear to everybody? Right, so we're going to have two cases where you're going against the wind or with the wind. Of course, if you're going with the wind, your speed is going to be faster, right? So what you would normally travel, whatever your rate is in the still air, it'll be plus wind, it'll be whatever your rate is minus wind, against the wind. What would be the time then with wind? Yeah.
6 and 40 over 60.
Good. 6 and 48 over 60. I like how you said that. Okay. Could I put 6.48? No, that would be wrong. Austin, why not? Why would that be wrong? Because it said it takes 6 hours and 48 minutes. Would that be same as 6.48 hours?
No, because it's like 6, because it's out of 60.
Yeah, it's out of 60 minutes, right? 60 minutes, right? It makes 1 hour. So you got it right exactly. And so what would be the time for then against the wind? That's a little bit easier. 8, right? 8. It's not simply 8. And look what I did. 6 and 48 over 60. You could simplify that as 6 and 4 over 5, right? Isn't that nice? If you could simplify this fraction, just makes it easier to do. So then, what will be the distance with the wind in this chart? It'll be distance is going to be rate times time, so it'll be R plus W times 6 and 4/5. Now, is it a good idea to leave it as 6 and 4/5, or do you think it's better to write it as a improper fraction? Improper will be better. Very good. So I wrote down 34 over 5. Okay. Of course, what about against wind? It'll be R minus W times 8. There you go. So go ahead and write it down. Any questions so far? Do you understand where I got these two expressions? And these are expressions, aren't they? What do we need to solve for these two variables? If you have two variables, what do you need, guys? You need two equations. Is there a way to get equation out of these expressions that we have here? How can we come up with an equation? We need actually two equations, right? Because we have to solve the system. Anybody? Well, let's read the question again. It says a jet can travel what? How many? What's your distance that you're traveling? 6,800. Oh, Victor, you have an idea? What do you think?
Would it be R plus W times 34 over 5 equals to 6,800?
Exactly. Didn't you get that? What about the other equation? Audrey?
R minus W times 8 equals 6,800.
Yeah, exactly. There you are. Isn't that right? Are we traveling the same distance? Going with the wind or against the wind? Right? It says from New York to Paris is about 6,800 kilometers, right? So that's those are your two equations. Why do we need two equations, by the way, here? Yeah. We have two variables, we need two equations. Does this kind of problem look familiar? We've done this before in first semester. Didn't we usually then do, if you're going to the same distance, why don't we then make these two distance with the wind and against the wind? Why don't we just put them equal to each other? R plus W times 34 over 5 equals to R minus W times 8. Why don't we do it that way? Why do we separate it into two equations? Because don't they represent the same distance? Do you know what I'm talking about? Why don't we make this distance right up here, right, equal to this distance right down here? Because it's the same distance. Why can't we just do that? Didn't we do that before in first semester? Yeah, Alvin? Actually, R plus W times 34 over 5 equals to R minus W times 8. They are equal. But if we're looking for equation, why don't we just make this equal to this? Why do we separate them into two equations? Anybody? Yeah, Katie?
I'm not really sure,
Mhm.
but it's like, it's gonna equal out to 0 equals 0 because they're the same distance.
Not. Not quite. Any,
Because it's like 6800 is also equal to.
right. Actually, what happens is if you did that, you can't solve because how many variables do you have? You have two variables, right? In one with one equation. Right. Exactly. So therefore, you have to have two equations to be able to solve these two variables. Now, in first semester, guess what? How many variables did we have before? Just one. Now we're using two variables. You need two equations. That's a little difference. Does that make sense? So in a way, you're kind of right. You can't really solve. You can't really because you have only one equation with two variables. Does that make sense? If you let this r plus w times 34 over 5 equals to r minus w times 8, you can't really solve because you have two variables with one equation. That's why we separate it this way. Now, what should we do then? How do we solve? What is the best way, do you think, to solve this system? There are many ways. Do you think you want to use graphing method? Probably not. What about the addition method? No, you don't want to use addition method? Because those are the only two ways we know. Oh, we could use substitution. Okay, yeah. Do you think you want to use substitution method? Let me show you a nice way to do this. By the way, before you do anything, when you have problems like this, by the way, wouldn't it be great if I didn't have this number right here, 34 over 5 and 8? Because look at these two left side of this equation. You got r plus w and r minus w, and you could just add them together and get rid of the w. Wouldn't that be nice if you could just could get rid of these numbers? Is there a way to get rid of those numbers? Two people see it? Because there is a way to get rid of those, and it just makes it easier if you do it that way. Victor?
For the first equation times 5 over 34.
Yeah, multiply by the reciprocal. What about the other one?
And then divide
Divide by 8, right? Go ahead, everybody do that. See what happens. So you should simplify these first, okay? It just makes it so much easier. And you will see as you do your homework, and as you do problems like these, whenever you have r plus w or r minus w, get rid of that number that's multiplying the rate, right? We'll just make it so much simpler. Go ahead, everybody's fine. So were you able to get for the first equation, what did you guys get when you multiply both sides by? 5 over 34. 1,000 on the right side, don't you? So you get r plus w equals 1,000. You see how nice it becomes? You see this equation just simply became r plus w equals 1,000. That's pretty nice. What about the other one? Claire, what did you get? When you divide both sides by 8, you got what? R minus w equals 2? Oh, okay. Did anybody? How many times does 8 go into 68, guys? 8 times, so you get r minus w equals 2? 850, right? Doesn't it? Okay, we get two equations this way. Is this easy to solve? Yeah, you just simply use the addition method. You see, simplify the equations. Whenever you get r plus w, r minus w, try to do that first, okay? Then when you add them together, what would then this become? We're just using addition method. You see the w's will cancel out. What's r plus r? Is it 1r or 2r? 2r, okay? There are two r's, right? 1r, if you forgot that, okay? There's an invisible 1. So then you get 2r equals to 1850. Divide both sides by 2. How many people got r equals to 925 kilometers an hour? Very good. If I know the r, is there a way to find w? Because that's what they ask also. Yes, how do we do this, Viviana? Yeah, you substitute r into one of the equations. Which equation is easy to plug in? The first one, r plus w equals 1,000. After it simplifies, of course, right? So if r plus w equals 1,000, w must be 75, right? Now, would it work on the second equation too? What would be 925 minus 75? Does that equal to 850? Yeah, so you can kind of check. So it works. So here's your answer. The rate of the jet in still air is 925 kilometers an hour. And the rate of the wind is 75 kilometers an hour. Pretty straightforward. Is that okay? Easy or hard? Pretty straight. Okay, easy. Good. I want to do number 4 first. Can we go to number 4 then? Because number 4 is a little bit different. It's not always going to be like this. But let's look at number 4. So number 4 says a motorboat travels 72 kilometers downstream in the same amount of time as it takes to travel 48 kilometers upstream. The current is flowing at 4 kilometers an hour. What is the rate of the boat in still water? Now, does this make sense to you? How come the motorboat travels 72 kilometers downstream in the same amount as it takes to go 48 kilometers? If you're going to travel same amount of time, how come you have different distance? Does that make sense? Yeah, Kaylin, what do you think?
Because the water's falling down.
Exactly. If you're going downstream with the same amount of time, right? Of course, you're going to go further down. Whereas if you're going, for example, if you're going downstream for an hour, right? You're going to go further downstream than if you were going up against the current for an hour. Does that make sense? And it does make sense. So you see, you go 72 kilometers downstream, right? With the current downstream going down, right? If you're going upstream or going against the stream, you only travel 48 kilometers with the same amount of time. Does that make sense? Yes? And they even tell you the current, the speed of the rate of the current is 4 kilometers an hour. What is it that we're looking for, guys? Rate of the boat in still water. Is that the only unknowns we need?
No.
There's another unknown we need to actually figure out. Yeah?
The amount of time takes to travel 72 kilometers downstream and 48 kilometers upstream.
Correct. The amount of time that takes to travel 72 kilometers downstream and 48 kilometers upstream. Exactly. And what is that time? Let's call it T. Very good. So that's it. And isn't that time going to be the same? Right? We're traveling same time, right? As you go downstream, right? As going upstream. So you're exactly right. There are two unknowns for this. The rate of the boat in still water and the time it takes to travel both way, right? It's the same amount of time going down or coming up. That's why the distance is different. So, go ahead and write it down. What kind of then, we're gonna still need rate times time equals distance, right? And of course there are two cases, again, downstream and upstream. Can somebody give me the rate for going downstream then? This time it's a little bit different than what we just had before. What would be the rate for going downstream? No one knows how to do it? If the rate of the boat is still, yeah, Gemma?
72 divided by T.
Uh,
I'm just kidding.
okay, we're calling R to be the rate of the boat, right?
Yeah.
And if that's R is the rate of the boat, and we know the current is 4 kilometers an hour, what would be the rate for going downstream?
Wait, what?
Okay, if I know that the rate of the boat in still water is R, they tell you that the rate of the current, which is 4. So how fast are you going downstream? 48 is the distance, right? These are not the rate. What's the rate of the boat? Isn't it rate of the boat plus how fast the current is going?
Yeah.
So what would be the rate for going downstream? R plus 4 is exactly right. Maybe it was so easy. You guys, yeah, don't think too hard here. It's not that hard. Okay, so it is R plus 4. Okay, somebody can tell me what the rate for this will be going against the stream. Stefan, what would the rate going against the stream?
Would be R minus 4.
Yeah, it'd be R minus 4, exactly right. What about time for going downstream? T. What about time for going upstream? T is same time, isn't that right? And because we're going same amount of time, guess what? The distance will be different, isn't that right? What was the distance that we traveled? 72, that's the distance. You know that's, well actually, we'll get there in a minute. But right now, isn't it R times T? So T times R plus 4, and the other one is T times R minus 4. And when do we use the 72 and 48? When we come up with an equation. Somebody tell me the first equation with the going downstream one. 2 people, that's it? 3. Gianni, what do you think?
The equation would be t times r plus 4 is equal to 72.
You got it. That's the first equation. Somebody tell me the second one. Chemin?
T times r minus 4 equals 48.
That's right. Is this so easy that you guys don't even say anything? What you got? Okay, so does that make sense?
Yes.
How many people agree that these are the two equations? How many people understand? How many people are not so sure? Please ask me if you don't get this equation. Does this make sense? Because we're traveling the same amount of time, the distance is different because you're going up against the stream and coming down. Okay? So now this one looks a little bit different than before. Should we divide both sides by t first? If you do that, then you get 72 over t and then 48 over t. It's not that simple, right? When you do that. So guess what? We're just going to have to, yeah, multiply it out. Distribute this t. So when I do, I get tr plus 4t equals to 72. Tr minus 4t equals to 48. Well, that's not too bad, is it? So which method should we use to solve? Yeah, addition. And it looks like if we just add to these two equations right now, I could get rid of the t. Does that help us though?
No.
No, it does not. Why not? Why doesn't that help? Sarah? Hey, how come it doesn't help? When I get rid of the t? You'll be left with so if you get rid of so if I add these together, the 4t will cancel out, the negative 4t will cancel out, right? You get tr, 2tr equals to some number, right? Does that help us? What do we want at the end when we do addition method? We want how many variables left at the end? 1. Now we have 2 variables. That doesn't help us. The other Sarah, what do you think we should do then? Don't get rid of the 4t, but get rid of tr. Get rid of the one with 2 variables in them. Then you could get an equation with 1 variable, and we could figure out what that is, right? Whereas if we do it the other way, it doesn't really help us. So you're right. So how do we do that then? We should do what first? If I want to get rid of the tr, I should multiply -1 to either one of these equations, right? I multiply the bottom one. So why do we want to get rid of tr? Because otherwise we don't get an equation with 1 variable. So get rid of the tr, and when you multiply both sides by -1 on the second equation, I get this. Now you could add them together. What do we get when you add them together? What's 4t plus 4t, guys? 80 equals to what? What's 72 plus -48? Huh? 34? 34? Okay, it's 24. Then divide both sides by 8. What do we get? T is equal to 3. There you are. So we were able to figure out t. What does this represent? T equals to 3. Time. For going upstream or going downstream? For both. Yeah, for both. So what do they want you to find, by the way, at the end? It says, yeah, what is the rate of the boat in still water? Well, we found t. How do we find the rate of the boat then? Any idea? Yeah, Lucia? Yeah, plug T into one of the equations. So I use this one. T times r plus 4 equals 72. Is that okay? Could I use the other one? Yeah, it doesn't matter. So when you plug in 3 for t, you can see that the rate is 20. So do you see how I got 20 there? The answer is what? The rate of the boat in still water is 20 kilometers an hour. Any question? So this one is a little bit different, but you get the idea. So whenever you get a system where you have 2 variables multiplying together, you want to get rid of that one, okay? Because if you don't, then it doesn't really help you. You end up with another equation with 2 variables. That's not good. Yeah.
You also have to write the time it takes.
Oh, did they ask for that? No. But if you wanted to figure out, you could actually. Well, we know what time 3 hours, but they didn't ask for it, so. Yeah. But you're right. We had to actually know what time, how long it takes, right, in order to figure out the rate of the boat. Don't we? In this case. Yeah. Any question? Because that's how we got the rate, right? Are we good? Let's go to then example 3. Example 2 is same as example 1, so I'm going to do it at the end. Okay, so I think you could do that by yourself. But let's go to example 3. Example 3 is a little bit different too. So let's look at example 3 now. Oh, we're going backwards because I want to do the ones. I want to make sure you know how to do the different ones. Example 2, like I said, is same as example 1. You could, it's easy. Okay, example 3, it's a bit different. Sally is planning a 3-hour trip down the river and back to her starting point. She knows that she can pedal in still water at 3 miles an hour, and at the rate of the current is 2 miles an hour. How much time can she go spend doing downstream? How far downstream can she travel? Okay. What is this asking? What's going on here in this problem? Can somebody explain what's going on? Hello? Anybody out there today? One person? Same person? Gianni, what's going on in this problem? What do you think?
It's going like, do you want me to explain
Yeah, what is this?
what's it asking?
Yeah. First of all, what is she doing here? She's going to go downstream, right? And back. That's the key. She wants to go downstream and come back to where she was before. Does that make sense? Okay. And what is it that we want to find? Yeah.
The time she spent going downstream.
Yeah, why do we need to know how far she could go down? How long she could go downstream? Because we want this trip to be how many hours? 3 hours. Does that make sense? Do you understand? So she wants to know how long she could go downstream before she comes back up. By the way, if I was her, I would do the other way. I would go up and come down, right? Because what if, like, you know, you get tired and, you know what I mean? So anyway, okay, so let's say that she's going to go downstream first and come back up. And she knows that the rate of the current is 3 miles an hour. And she knows, no wait, is that the rate of the current? 3 miles an hour? No, that's that's her speed, right? In still water, she could pedal 3 miles an hour. And then the current is 2 miles an hour. Is that okay? So what's our unknown then? How many unknowns do we have here? There are 2? What are they?
How much time she spent going down.
Good. Let T be then how much time she spends going down. Is that okay? Very good. What's the other unknown?
Would it be like
I'm sorry. Say it again.
would it be 3 minus T?
For the upstream, you're right. So this time you really don't need 2 variables, do you? Alvin, did you want to add something to this? So yeah, because we know the total time, it should take 3 hours. If you let T be the amount of time it should go down, then it's got to be 3 minus T to come up. Does that make sense? So sometimes you don't need 2 variables. In this case, you just need 1. I think it's easier this way. Yeah.
How do you represent the distance downstream?
Good. We'll get there in a minute. Very good question. How do we represent the distance going downstream? Well, we'll get there in a minute. So we're going to need rate times time equals distance. Of course, again, we need 2 cases, downstream and upstream. Can somebody tell me the rate for going downstream? This is kind of easy. Because we know how fast she could pedal, and we know the rate of the current. What is the rate going downstream? 5. Where'd you get 5 from? 3 plus 2. What is the rate going upstream? 1, because you do 3 minus 2, right? Because they told us this time. That's why I said it's a little bit different, right? Where the other questions, you know, we had to figure out what those rates are. Now they give us the rate. We don't know the time though. What is the going downstream time again? T. That's what we want to find. And of course, if T is the amount of time going downstream, we want to make sure it's 3 hour trip. So yeah, the time coming upstream is 3 minus T. Is that okay? Yeah. Like I said again, I would go up first, right? Because what if you get tired, really? Like, you know, you don't want to go downstream first and come back up, you know. Anyway, so I stopped. Okay, then what is the distance for going downstream? Yeah.
Is it equal to each other?
Hold on to that. Yes, you're right. Because it's a, what kind of trip is this? This is a what do we call that back and forth? Round trip. Remember round trip? We did this in first semester. So you're right. The distance is the same for both of these, and it's good that it is same because we're gonna get one equation with one variable, right? So what is the distance then? How do we represent this distance? Well, isn't it rate times time? So the distance for downstream is 5t. What about the rate for the upstream? 3 minus t. Okay? Times 1, which is just 3 minus t. And since it's round trip, you know the distance is same. So how do we come up with an equation? 5t equals to 3 minus t. Does that make sense? So in this case, we get one equation with one variable. That's how you do that. And is this simple to solve? Yeah, just add t to both sides. Then divide by 6, you get half an hour or 30 minutes. So you want to spend just 30 minutes going down because it's going to be, how long is it going to take you to come up? Yeah, 1.5, so 1.5 hours. Oh, 2.5 hours, 2.5 hours, you're right. So like I said, I would I would make sure I go up first and come down. You know, coming down, you don't have to go down fast. You could just rest. Does that make sense? So is that what they asked for? It says, what is the speed of the boat? Oh, that's not. How far down? Oh, see, if you did this, you'd be wrong. You don't just write 30 minutes because they ask you what? How far down can she travel? So they don't ask for the time, but we of course need the time to figure out. So they're asking for the distance. How do you find the distance, guys? 5t. So you do 5 times 30, right? Do you do 5 times 30? No, then you get it wrong. 5 times half, because it's got to be in terms of whatever the rate is given, right? It's miles per hour. Was it kilometers per hour? Yeah, it's miles per hour. So you need to multiply by half, right? So if you multiply this by half, I think it's 2.5. Is that right? Yeah, 5 times 5t, right? So it's 5t, not t. So 5 times half equals to 2.5. Okay. Any question? Just do simply this. Are we good? All right then. Then I would like you to then all try example 2 by yourself. Example 2 is exactly like example 1 now that we have time. Oops. Example 2. Do example 2 by yourself. I'll give you time. Go ahead. You shouldn't have any problem doing this one. Okay, of course, help each other out. Okay, go ahead. Okay, so I thought it was going to be easy, but I guess it's not so easy. Sorry. So the one first of all, a boat can travel 60 kilometers downstream in 3 hours, right? Correct? And then we want to come back up. Guess what? If you're coming up after you went downstream, you're going upstream. You're going up against the stream, aren't you? And it takes 5 hours. And does that make sense? Yeah, it's a round trip. You're going same distance, right? If you're going same distance, going down, it's going to take less time than coming up the same distance, right? You're going up against the stream. So what are your two unknowns? Let R to be the rate of the boat in still water. Then let W be the rate of the current for the water, okay? So then you're going to have two, again, you're going to put them into the chart, okay? So, okay, then who could tell me the rate with current? R plus W. What about against the current? R minus W, correct. Okay, what about time with current?
3.
What about time for against? 5. What's the distance with current then?
3 times RW.
What about the against?
5
Oops. Okay. Somebody give me the two equations that we're gonna get. This is just an expression. Yes.
3 times R plus W equals 60, and 5 times R minus W equals 60.
Good. They told us it was 60, and you're doing round trip. The distance is the same. Right? Do you see how we get two equations this way? Should I distribute these 3 and 5, or should I divide both sides by 3 and 5 first?
Divide.
Yeah, divide, so you know it makes it easier. Go ahead, everybody try, because you know 3 goes into 60 and 5 goes into 60. If it didn't, then I would just distribute. You know, but I know that they go in, so why not simplify it that way first? Go ahead. Now you should be able to do this without much problem. Go ahead. I'll give you time. All right, Stefan, what do I do?
You-
Yes.
You get R plus W equals 20.
Good.
R minus W equals 12.
You got it. Okay. So you want to simplify this first, and you're going to add them together, aren't you? Okay. Oh, I'm sorry. Viviana, what do I do when what do I get when I add them together?
2R equals 32.
Good. R plus R equals 2R, isn't it? So 32, and then divide both sides by 2, you get 16. How many people got 16 for the rate of the boat? Very good. Then what is that all we wanted, or did they ask for the rate of the current? But if they did, could you figure it out? What would it be? 4. You plug it in. R plus W is 20. R minus W is 20. Okay. Does that make sense? Yes. Again, how many people got this again? Easy. All right. Good.